Well, this time we're going to talk about categorical data displays. So categorical means not quantitative, means categories. And ordinarily the way things start off is you have a frequency table. So here's a frequency table of number of students in each college on campus: STEM, CHAS, HSP, KEEPS. 586 students, 1422, 1120, 875. And over here for convenience, I've computed the percent. So 586 divided by 4,000, oh, there's the total, 4,003. So the total here is 4,003. Take 586 divided by 4,003, you'll get 0.146. So that's 14.6%. We can check these. They should add to 100. We might have rounding. It's a tiny bit of rounding there. Okay, so we want to talk about graphs, not tables. So those are tables. The graph we're going to make is a bar graph of the frequency. So over here I've got a count, or a frequency, and we arrange it so 0 is where the x-axis is, and then we have equal size units up this direction to encompass these kinds of values. All right, and so then the stem height is 586, maybe this high. So we make a bar 586 tall, and then 1422, maybe like this. And I'm trying to make them the same width. The reason for making them the same width is that way area is proportional to the number of observations. Since the height is the number of observations, if the widths are the same for all the bars, then their areas represent an amount. And we want to do that. So here we go, 1120 tall. Try to make it the same width. And finally, 875, maybe here. So that's just a good old-fashioned bar graph of the frequencies, or the counts. Okay. So on this axis, I've got the college. On that axis, I've got the count. So this is the categorical axis. No special order implied. So that's just the order the data came. I just made a graph in the order. If you want to make a Pareto graph, you arrange things in increasing or decreasing order. So what that lets you do is compare side by side quantities that are closer together to the same size. Also immediately identify the ranking in terms of counts. So the lowest count here is STEM, so I'll put 586 here. Well, let's put STEM there, 586 here. The next smallest one is KEEPS, 875. And then HSB, 1120. And finally CHAS, 1422. Once again, same width. So sometimes you have categories that are spread out and they have almost the same height. And if you put them side by side, you can tell which one's bigger. Maybe that's a reason for doing Pareto graphs. Another option is a relative frequency graph, where instead of graphing these amounts, we graph the fraction of the total. So that's like graphing percents. So 14.6 is 0.146 as a fraction, a relative frequency. So put here, over here it said count or frequency. Here we're going to put relative frequency. The relative frequencies, let's see, here we are. They get as big, almost as big as 40. So I'm going to go 1, 2, 3, 4, 0.1, 0.2, 0.3, 0.4 is my units, and down here 0 again. STEM is 14.6. That might be here. All these graphs should look identical except for maybe the scale on the axis or the order of the bars. CHAS, 35, what's that 3 here? 35.5, maybe like that. And then HSB 28. And keeps 21 and change. Okay. So those are three standard graphs of categorical data. If you have counts, we can just do a straight up graph of the counts. Make sure 0 is there so that a height is proportional and area are both proportional to the number of observations. Sometimes when there's no special order to these, we often put them in increasing or decreasing order, so easier to compare. And sometimes we don't actually care about the count, we care about the percentage. We'll put relative frequency on this axis. So 10, 20, 30, 40%, or 0.1, 0.2, 0.3, 0.4 as the fraction of the total. And we've done the kinds of graphs you can think of. So we're going to move on to some more graphs in a minute. I got to make a new slide, and we'll see you in a minute.